Hello everyone, welcome to my channel. Today we are going to see the Motorola RTUs and how it is functioning. And this Motorola RTU is specially dedicated for radio communication and also for other wireless networks such as GSMs or microwave communications, etc. So this Motorola ACE application is widely used in everywhere for especially for irrigation networks, oil and gas, and also various applications. Okay, now we will go with Motorola ACE3600 system troubleshoot. This is the software we are going to use in the Motorola. Double click that Motorola ACE system troubleshoots 20.60 and you have lot of versions. It's uh, currently you have 22 version. So you can open this application and you can see here there is readme, STS, application program, MDLC communication drivers, protocol analyzers, stop, MDLC communication driver and STS. Okay, so our main application you need to be focus on STS because these all functions which we have here, everything gets included in the STS application. So if you need more about this STS application, open here STS manuals and you can find all the manuals related to this Motorola ACE3600. So double click the STS application and it will open the STS framework .exe. See, once it's opened, okay, once it's opened the application, see you already have the existing files here. Okay, here open projects. Okay, but now in our case we are going to create a new application. So click new project and it will ask you the project settings and give you here the names. Like example, I am going to give here as demo and description just for demo purpose. And this is the location the project will be saved as demo, like STS 2060 project/demo, and the default system address is 0, but most of the project we will give the system address. You have to put the same system address. So I am keeping here system address is 1 and MDLC network is MOSCAD, or you can give any name, but default you can give MOSCAD. So once you enter that one, it will created here, the project will be created at this project demo.spj. spj is the extension of the file. Click this one and it will create the new project for us. See, now it is opened here as inventory and you can see here FEP, RTU, ports, IOs, everything. So here you have in FEP you have IP gateways, 4600 gateways, and if you give and you can see the legacy, this is for the old IP gateway, and this is the three. See, you can find here ACE1000, this is also a gateway for the Motorola RTU, and this is the CPU you are usually selected for irrigation or for any applications. See, here you have here CPU 3610, 3640, CPU 3680. Okay, and you can see the previous versions also for each and everywhere. See, it will started from 14 version up to 19 you can use also, and also this is the last version which you are using with the version 20.60. So I am going to select this CPU. See, and also if you see your inventory, you cannot see anything now. See, this is the area and you can see here area, site, local sites, everything. This is the symbol what you are created here. See, this means, this color means this is system, and if it's colored open like this, it means area. Okay, I will show whenever we are creating here. And see, you can see here also diagram view, table view, new area, move to area, up area, links. So first I will select here, and I am going to select this 3680, drag and drop here, and it will open add RTU. From this add RTU general, you can find the site ID. Example, I am going to give site ID is 1, and you can give the site name, example demo 1, and this is the firmware version which we selected. You can change the firmware version later, and the descriptions, and here, even here you can change the CPU type later on if you need, because this is the latest version. If you need the 3640 or 10, you can select here. And if you need to make a redundant, because 3680 it will support redundant CPU, if you need redundant, select the redundant CPU. It will automatically create for redundant also, and give OK, add. See, it's added here. If you need, you can check. See, now it's added here, site 1. Double click again, because I need to explain the other functions here. See, before going to these functions, I will show here what you have in this file. Here you can see new project, open project, close project, save as, import the gallery, and these are common for everywhere, every software. And here site, you can see the site views, and also copy, delete, open site folders, toggle FEPs. This is not required, this all. See here the download, upload, everything you have the functions here also. And also you can find monitor, change the RTU version. I told you before, this version you can change from here. So if you click, you can change the previous versions. Okay, so now we will go with the site date and time, secure, unsecure, open application, network editor. And also you can find the other, because it's all disabled, because still you did not make the proper application, so it's disabled currently. And you can find the adverse logos, etc. Okay, if you go for systems, you can find new area, add command, and also the descriptions, paste. And from here you can find the synchronize, set the address. Before we set at initial stage just 1, you can change the system address here as what you need. And also this is same bricks system address, and also you can set the MDLC network. Motorola, this software will support MDLC network, Motorola data link communication. Okay, this is the communication. It is one of the strong communication, and it's using 7 OSI layers in the communication. So you can use that communication layer from here. And also you can check the network managers, because this all it will be useful for communication time. For currently now, see, this is application manager, same here. And this is the IP conversion table. This is also can be used during the communication stage. I will show detailed on later or on the next video. And for the site table manager, also you can use for assigning the site tables for the communication purpose, and all it is going for use for communication purpose. Okay, and here you can use this import site properties and export site property. If you need to add some functions here, like the properties for sites, you can add here. And for this one, communication setup, stop communication driver, change the MDLC protocol. These 3 functions you can use for communication purpose. Okay, in our now currently now I am going to communicate here. Sorry, I am going to show here all the details. See, here you can see date and time. This one, see, if you double click, you can give local, and you can get the date and time from the site, because now if it's connected with local sites, you can take directly. If you connected with the remote sites, you can take the site and date from the particular network, and you can it will get the reading from the site, and you can set the reading from computer date and time to the field also through these sets. Okay, and for this logger you can find all your diagnostics, error loggers, diagnostics, and time lag, everything from here. If you give local and give start, it will get the reading from the site, from the RTU or adverse. Okay, so for this download, sure, this one when you save the project, it will ask you to download. So this is the file you can download: site configuration, network configuration, remote system file, and site source currently. But after you configured all this, like you assign the program part and also the third party protocols, everything, it will show you here at the time. And for upload from the RTU to your application, only you have only some functionalities only, like example site configurations, and also you can upload some functionalities like some backups only, like not complete application. You cannot upload from the RTU to the STS application, because here there is some limitations because of security purpose. And if you go for hardware test, sure, you can check the hardware complete test from here. Just give read RTU, and read RTU, it will read the complete diagnostics, and also you can monitor and control the hardware test during the FAT or SAT time. Okay, currently now you've seen these main menus. Now we will go for sub menus here. General, sure, I told you before, this is the site IDs, firmwares, and description of the project. Okay, I will give you here demo one. And also I told you here before, you can change the CPUs. And for the port, you need to configure the ports. See, this port is for USB host only currently. Sometimes you need to connect your radio also through this port. See, Motorola, this is the radio you can connect directly from this port. And also you can connect this. See, you have another option, serial USB host. Okay, this one also you can connect through this radio. See, non-IP and IP radios also from this hub one. For the hub 2, if you configured, you can use the same for the Motorola radios, and also for the other third party radios also. And if you go for the this P1, here you can select what you need exactly. You can connect even your radio, RS232, RS485, or TCP/IP. Okay, so for my current situation now, I will just select radio, and I will select the general radio, and I will keep the modem FSK or DPSK or COS. I will select COS, FSK, and you can select the radio channels, like example radio 1, radio 2, like that, because this all, if you are familiar with the communication systems, you can understand this radio configuration, because there is some modem types, and also it is conventional radio. See, there is trucking radios like this. So and other thing, for this S1, you have here, see, RS232 or RS485. You can configure any one of the device here. See, if you configure for RS232, you can put, there is many options: user port, local computer, RTU to RTU, external modem, dial-up modem, protocol analyzers, third party protocol, GPS receiver, PPP, point to point communications. This is for RTU to PIU, this is for Ethernet ACE only. Okay, and also if you based on your selection here, it will change the data speed, link speed, everything. Okay, for example, now I am going to configure for third party protocol, so I will use RS485, and I am going to select here multi-drop or third party protocol, or what you are going to connect, third party protocol, and connected to master or slave. So you have, say, and it will be connected to now to the connected to master. If I put this one connected to slave, and you will connect to the power meters or VFDs or any of third party slaves. Okay, and here S2, it will be used only RS232 only, and you can use this one for computer, example for accessing the computer. So I put local computer, so you can make, and I can put the speed also. What you are changing in your device drivers, same you can put here 9600 or 19200 or 111,500. So you can select the speed. And for Ethernet, sure, if you are going to use the Ethernet, you can select 100 10 or 100 BT, and you can select static or dynamic. Okay, and you can put the IP address. So this is the first step you will configure for the port. Okay, after that you can go for IO configuration. This is the one you are going to configure the Motorola IO slots here. See here you can select, there is many options, like example I am going to select one mixed IO, because one of the beauty of the Motorola, you have mixed IO card, 16DI, 4DO and 2AI card, and you can select the mixed IO cards, or you can select there is two types of DI duo cards, like two types of DI card, DI FET and normal DI IEC, 24 volt IEC. So based on your application you can select the IOC. You have lot of cards you have here. So you have say 16 DI, 32 DI, fast 24 volt IEC type 2, or 24 volt or 48 volt, like this. So you can select the card based on that. And for analog input, I just select this one as 4 to 20, and for analog output I will select, because now I am for configuration purpose I will use only similar things, small one, 16 DI, 4 DO and 2 AI, sorry 4 AI, and also 4 AO and 8 AI channel for configuration purpose. If you double click this one also, you can make the faster counters, see, disable or enable the functions, and also you can put AC or DC, and also you can put the countings like the DI filter, and also for AI parameters you can put 50 or 60 Hz, and you can select the AI filter, and also you can select 4 to 20 milliamps or minus 22 plus 20. And after you select, similarly you can select for the AO also, you can put plus 20 to plus 4 to 20 milliamps and give OK. So you selected the IOs, go to the advanced. You have like lot of features in the advanced. So you can see many functions, see core dump, DNS client, dynamic, and also the dynamic error logger, faster counter, firewalls, gap ratios, hardware test, IO expansions, see NTPs, PLCs, power management, power supply, PPP, like. So you don't need to configure this one for currently, and this is the basic configuration of STS, and you need to be add the application now. Okay, now see, you currently you don't have any application, and see, if you need to create new application, make new, or you already have default, see it's created, and you can see you need to create new, and here lot of options here for applications. So it's create a new application. In this, here you have database, process, and IO link. IO link it will not come until you will compile this application. Okay, and here for the user tables it will come only qualifiers, and for this system tables it's have lot of functions already inbuilt, RTU to RTU controllers, RTU to RTU communication buffer, time date, index, reserve flags, monitors, like this. And for constants you have many things like ASCII tables, port numbers, names, baud rate, year, date, time, constants, timer, triggers, everything. This is for the main application. If you see, what I will do now, I will just compile and I will save. Just close. See, it will ask it's created new, so you can select to the application. Once you give apply OK, see it's added here .adb file. Okay, this is the basic step how to create the configurations and logic and the application. Okay, now I need to import the file from other project, because see, usually for Motorola application, if you open the application manager, you have lot of inbuilt functions already available now. So you cannot create from zero or from scratch. because the Motorola application, it is dedicated for wireless communication, one-to-one networks, and there is lot of functionalities inside. And they already, Motorola team, they already created many applications for oil and gas, for water, for irrigation networks, and also for many process applications. So you don't need to make from zero. Okay, so you can use that application, generic application, we are telling that name. So that generic application you can import, and you can use the functions from that one. It is very easy. Once after you create, after you saved it, come IO link also. From this IO link, see, you already have the modules also. Okay, so if you need to create from zero, you can create also. See, if you go here, I am going to add new append table, single or multiple. You can add the table name, example digital input, and you can give any, see, you can give, there is lot of options here. Integer value, integer parameter, timer minutes, seconds, mapped digital, mapped value, discrete, value input, value output, real value, real parameter, scaled input, like this. So you need to be select for your application for DI. Example, DI means you know already discrete input, DI. See, you can select this one, and it will ask you, you need to make a multiple column or single column. If you use only single column, it will create only one single column with name and value. Okay, this one example, now I need for, now currently it is 0, so I will give you any number like 32, 31, it will start from 0, so it's created from up to 32. Okay, so just I will save this application, and I will make for AO example, or D or anything, no issue. AI, select, give analog input AI, and here I will give multiple column. Okay, see, multiple column, it will not ask you the data type because it will be add after that. So it just created here multiple column. See, it is asking now the column name. I will give AI input integer. So I will come to, I will select here AI. See, here you have option, you need to select VOBI, value input. Okay, DI, DO, AI, AO. Okay, and you can select here up to 15, 16 channel. Okay, and also you can select add the another column, and you can put integer something, or real to integer, or integer to real, because you need to make a scaling, no? So I can, otherwise I can use the scale. I will put scale. I will add, see, it's added scaling. So the scaling, it's already inbuilt functions, and you can use, if you put scale, it will automatically create the 3 functions. Okay, so similarly you need to be add like many bits, integers, real parameters, and there is many tables. You can add up to 64 tables as per your convenient, but the Modbus after 32 or 64 you cannot use the Modbus registers now, because you are connecting these all the tables with the Modbus registers later on. So see, now I already added, and also if I go here, see, I am going to add appendix process, and I am going to add some functions called like for test, and here, see, this will be main process. Okay, but what I will do now, in the main process, I am going to add rank, and put rank 1 R1. Then you can create your logic. Example, here you can give, but you cannot make now until, because in the database you created only few. So say you can select only particular things only. So you cannot added more for these functions, because you added only here. You can add maybe, see, still you don't have any names. So I will give you DI1, DI2, DI3 example. So when you are saving, it is asking that you cannot save because this is already opened. It will save, but it will, this rung is opened. So you can give now, if you see here, I can give now DI1. See, I added. But if if it's not added in the database, you cannot create, you cannot add any other variables here. See, if I give run, it will give you error, variable not found. I don't know my. Okay. So what I will do now, I will close this function. I will delete and close. So you can see it will not connect also because your it's not, it is opened, your function is open, no? Because you did not complete the logic, so it is giving error. And you can give any like example on opened, and I will give any command like di2 so for test. It will add. Until you are not linking, it will not affect, because you need to link the analog, see all the inputs here, di, you need to link your di here, then only it will communicate the di frame. So you need to be make frame 1 module 1 and analog input 1. So this is the basic input I linked for di1 only. See, better I will show one best example so you can understand the complete application, because here I told you already you have generic application, you don't need to create from zero. Okay, so what I will do now, I will close this application. See, this is the old one. What I will do now, I will go here, I can see, okay, sorry, I will go here, application manager, and you need to be browse and import the file. See, once it's browsed, you have some applications here already, no? So what I will do now, I will open any one of the application demo. This is the demo what we used currently. This is test. I will see there is any application available. See, there is no application. Okay, I have one application here. See, I have application. I am opening this application and I am going to connect this application now. See, now I already connected that application. If I open this application, you have a lot of functions and you have a lot of tables. See, and also the IO links are also connected. So therefore I told you each application they already created as generic, so you can use the same application in everywhere. So what I will do now, I will close this application. Again open your application which we created here, demo. See, from this one again I will go with what we created at first earlier time new. Okay, I will add in our application. Yes. See, this is the application at when you created at earlier. No? So from here what I will do now, I will add some additional values for some tables. Example, see, just we will add some user tables. Example, I will give one is for timer, single column, and give timer seconds. And you can give whenever I need to add, I can add the timer. Example, I will add some timer called delay 1. I will give second, maybe 5 seconds. You can give here 0.5. This is 5 seconds. And I will add whenever I need, I can add the timer. And I can add one more called bit. Bit registers. See, it will come under, it's there already bit here. So I can put boolean, otherwise boolean. And for this one also I can add whenever I need the boolean address. And I will add one more called integer. Integer. And here I will give, there is integer here. See, integer value, add this one. And for real parameter, you already have here. You can add the parameter here itself. I parameter. See, integer parameter. Okay. So what I done? I added one DI, one AI already. Now I will add one DO. Digital DO. And I will add this one as digital output. And also I will add one more function for analog output. AO. And here I will give analog output. Value out. So we added some of the tables. See, now I am going to add one small logic. So for that, you already created before now R1. From here I am planning to add one small ladder logic just for testing. See, now I already added DI, AI, AO like this. So this one DI already we created up to 31 registers, and I will give here DI4, DI5. Even if you need, you can give like this is pump 1, example be DI1, or you can give here pump, some name like pump run, pump trip, or anything what you need. For our current purpose, just I will give DI1, DI2, DI3, 4 and DI6 and 7. And for AI I will give the same name. See, here I cannot enter because this one already it is considered AIINT. This is the input values. So I can add this straight away, or I can add, because if you make by single column you can add by names, but if you add it by multiple columns it will take directly within this address AIINT, comma 0, 1, 2, 3, 4 like this. For DO, see if we added like a single column, no? If you need, you can make a multiple column and you can use directly DO itself. DO comma value comma 1, 2, 3, 4 like this. So for me, just in my case, I use single column now, so I can use example 4 column, and I will use DO1. I will use DO1, DO0 or DO1, DO2, DO3, DO4, and it's not like a DO5 because we have only 16-bit 16DA 4 DO, na? So I can use up to 3 only, so I put 3. Once you added, just give save. And for analog output, you can give also example 3 channel. 3 means 0 to 4, that is total 4 AO. Here you can give AO0, AO1, AO2 and AO3. So you already created the analog output also, AO0 up to AO3. Okay, now I need to link this address from physical to this table. Na? So for that, what I will do now, I will go here DI. I need to add this frame module and IO channel. See, I will give directly 1, and I need to give here input 1. And this DI2, I will give 0, module 1, and channel is module 1, and IO channel input 2. I will give 0, 1, input 3. Okay, similarly we will add for all input 4. And input 5. For module 1, input 6. 0, 1, input 7. So I will add for DI, I added almost 7 DIs, and for AI I can add 0 AI for module 1. See, I analog channel 1. Even you can make a browse like this, or you can type directly. See, A2. Or you can make a browse, you can do like this also. 3, and here analog input 4. AI4. So I added 4 channel. For the scaling also you need to be at the same way. 0, first one, A, analog input. This is for scaling. 1, analog input, second, and you can add for this third channel, AI3. Similarly for the last one, A1 and AI4. Once you finish, go to DO. Add the same way for DO 0. See, if you have doubt, you can select your IO information. You can see 0th frame, first module. You can see 16 DI, 4 DO, 4 AI. Okay, now we are adding for 4 DO. See, if you cannot find the second module, you can find, but it will be not assigned anything. See, only module sleep, power supply out, but you cannot find the DO. See, if you select now, you can find DO. See, So you need to be select properly as per this module selection. Zero, first module, output 3, 0, 1, output 4. So we selected the analog digital output. See, once you make exactly, it will come tick mark. This means you selected all the rows. See, if you are keeping something empty, it will not come tick mark like this screen. So this will be give just warning when you are compiling. You can find the warnings only. Okay, but it will not affect in your application. See, for analog output, I will complete now. See, analog output is second channel. So you can put true and select A. See, analog in output, because there is two things, current and voltage. So you are selecting current currently. 0, 2, analog 2. 0, 2, analog 3. 0, 2, analog 4. So we see, once you selected, see, these two become green because we filled that complete table or complete rows. So I will go to now in the link. See here now DI, DO, AI and DO, all the 4 channels already linked with the physical signals because you already linked here. So in the database now you already created some boolean integer like that. So I can add, before that I will add here some, for testing purpose I can add some boolean. I will give some number like 4 boolean currently. I will give or bit 1, bit 2 like this, bit 1, bit 2. See, you can give any names, but I am giving for testing purpose, I am giving the name called bits. Okay, bit 5. And for integer I will add here also almost 4 integers, like 4 means 5 integer total. int1, int2, int3, int4, int5. See, so I already added some integer values, some boolean, and also I will add some timer. Instead of delay I will give timer 1. Timer 1. I will add similarly 3 timer. Timer 2. See, default what's created here, it will take the same. If you need, you can reduce the time. Example, I will put 4 seconds. Timer 3. Timer 4. Okay, so similarly you can add example real values per. See, you have many functions here. You can see, if you click, you can find timers. We have 4 different timers, and also mapped values, map discrete inputs, discrete bit, discrete inputs, discrete output, value input, real parameter, scale value, PLC. This one you can use for third-party protocols to read the power meters or VFDs. Any other third-party protocols, you can use this PLC DI, DO, PLC VI, VO, these functions. And also you can read directly PLC real values also, and also real output. And also see you have mapped bytes, mapped long byte parameters, long parameters, IP address, everything. You have many functions. Okay. So based on your application, you can use these functions. But see this STS application, it will support only ladder logic. But this Motorola, it will support even C functions also. But it requires separate, not from this STS tool. There is some other tool called C toolkit. From there you can use this STS application for the C language. See, now already we created database, we made the IO link. I am going to add some functions here. I already told you, no? You can put some DIs. For the DIs, where you add a dear boolean. Okay, bit. Same I can give here. See, I can give now some bit for maybe you can consider this DI is pump run or pump remote. Okay, the second one I will give no trip. Example, this is you consider DA3. So DA3 is no trip. And for this one I will give bit 1. Bit 1 you can take that temporary bit. Okay. Once the pump is in remote and the pump is not trip, then it will go to this temporary variable. And after this temporary, with the temporary variable is enabled, like bit 1, then I will go to operate one timer. Okay. So this timer I can use timer 1. Okay, 5 seconds. After 5 seconds, I need to activate the bit. Here I can use either this method, or I will do one thing. I will take directly with the timer here. See, once this bit is on, I will move to the timer. Once the timer on, and after this 5 seconds, I can latch the input. Okay, so I will put the one like output out 1, or I can check before I am doing this one. Check this one, DO1. So the output command will energize once this logic will satisfy. Okay. So when the timer will need to be reset, either if any one of the DI is off, or I can reset the timer. See, you have already many functions here. Normally open, normally closed, equal, less than, not equal, and greater than. And this is rising edge, this is falling edge. And you can use here normally open open relay, and here close relay, latch, unlatch, timers on, timers off. And this is RTU timer, counters on, counter, count up, count down, reset, send. There is lot of functions. This is the basic function what I told now. And you have other functions, and or, and also calculate, scan, lot of other functions. See, for me now I just reset this timer. So I put timer 1. So what happened after this time? Once it's latched, it will reset again, and it will wait for the second cycle. Okay. Now when the pump should be off, if there is strip, I can put the same condition. It's reverse. See, I will put if there is pump is not in auto, or the pump is trip. This is the pump trip, no? DA3. Can use DA3 pump trip. If any one of the condition is satisfied, If you need timer, you can put the timer also, or you can put directly unlatch immediately. See, I will put unlatch DO1. So if any of the condition or any one of the two condition is satisfied, it will be off immediately. See, this one now it's not managed. So what I will do, if you press F9, or you can see here normalize, it will be automatically arranged. So this is the basic function or basic ladder logic you need to be create for your application. Okay, you now you created the basic database and you created one small logic and you link with the IO link. So now after you made, this is your compile, just click compile. You can find all. See, I already told you now before in the IO scan, some of them you not completely satisfied, so it is showing that it's not scan, not I think it is not linked. Some of that, see, it's not defined, some of them like this. So these warnings, it's not an issue. And what is telling that some DIs which you created, DI, AI, DO, this is the signal from PLCs, na? This one. See, for this one, you has to make a scanning. For that one, what I need to do, see, before this function, I can add one more function. See, here you have two things, na? Up and run, up and process. Up and process, and you can give scan. Sorry, up and run, give process as scan. Yeah, because it's already used. So what I will do, I will delete the old one because I created here wrongly. So now I will add up and run, give scan. So here what I will do now, I will put directly, I will use the scan here. You have one function called scan. What I will do now for this one, I can put the same name. See here DI1, sorry, DI, scan DI. DI1. Okay, so you have to give, because it's telling that the name in table it's not scanned, so you can scan DI1. If you use this complete function with multiple rows, this is discrete DI, so you can use here DI DI1. See, it will show you which input it is scanned. So I can put here DI 0, up to 31. Column name DI1 discrete input from 0th module, module 1, channel 1. Here, just go here, check it is DI. IN1. Okay, I will add for another scan for AI. See, from here, either here I can give AI table, integer AI. Here you can find all what you already configured here, you can find here all. See, I can give AIINT. Here also just click and you can find for DI. See, I told you before there is two difference. From the here I given as single column. Single column means you have to define all the scan. Yeah, you scan DI1, DI2, DI3 up to DI7. But if you make same like a multiple, see here I made this is 5 multiple column. So multiple column you can define only this function. Therefore it's taken directly with the AINT. See, I will make again for another DI here. See here, go here, give multiple, and I can give here digital underscore input. See, now I created digital input. So it is asking me now to create DI. Okay, and I will give you here digital. And I will give here even like a 16, or I will give 15 here. 15 means it will take 16 registers. Okay, now this is digital, na? This name. So what you need to do here, see, if I make a scan here directly, it will take, if you put digital, it will accept, because this one you add for complete digital scan. But if you made by single column, so it has to give one by one, DI1, DI2, DI3 like this. Or similarly you already had DI, and you can give for AO also. You has to give all AO1, AO0 up to 3, and also DO up to 4. Therefore whenever you are doing, better you can make with multiple column. At the time you can find all the formats like addressing directly. You can make a scan. Okay, because this scanning is very important during, because the whenever you are taking the PLC like third party devices or anything, you have to make a scanning at initial stage. Okay, so you made one small function and one small logic, and if you are using it, this is the main function, this main process, you are making many process. Example, this is the main process, then you are adding many process. If you are adding here some logics, see, I can add some logic here. This is, you can put run 2, and if you are adding some rungs here, at the time the main run you have to give this one directly to scan this run, because example I will show you. Put scan and put this this process name called test. You can put test here. Sorry, wait. Oh, sorry, not scan. You have to give the function called jump. This means from the main process it should be jump to the other process through this jump function. See, test. I am giving here to normalize. So once it's finished this, once it's scanned by the second run from this place, it will jump to the test. Otherwise the run will not work. It is giving error because here you did not added anything. So you can delete this run R2 and make scan now again. See, you have one error. The run one does not work because the empty compiler. Okay, you have here empty compiler. Therefore it's not added. So what I will do now, I will add here one small logic. Okay, I just add one normally open and one normally close contract. To make something it is there in the run. So I will add here DI2 and here bit 2. Okay, so now I am going to compile. Okay, still okay because it's not connected. I will check now again. Okay, what I will do now, I will see, you can see the warning here, JSR. To rung is allowed in a rung only in a single output element. Okay, this is for main rung scan. In this place, main rung scan JSR function. To run is allowed in a run. Okay, this function to run, you have to use separate function. Not, you don't need to mix up with any other functions. Example, see, I will put jump. JUMP. Okay, here you can put this function jump na jump to run. See, now you can add this one test. See, now there is no error. See, now you can jump to the second logic through this jump. So this is the basic ladder logic you can create here. You have all the functions here, and from here you have, see, this is just normal file, edit, view, and here this same database step process IO links is available. And here in the ladder logic, what you have in the right side, you have these functions, and also here you can see some of them like look, symbols, monitor, like this monitor. After you download your application, you can monitor the site here. Once you get monitor, you can see the online values. Okay, this is for this monitor. And if you go for applications, the settings, you can find, see, this is yes, auto scan, reload, and this is some functions for setting the application. And you can distribute this IO link. You created the IO link. Now these IO links you can distribute to the other program areas. So for the run times, you have all compile, all the sites, compile, download, and compile and download. These are the functions you will use here itself. Compile, download, and monitor. And this is the site name, your local site name. And if you are making by remote, see, if this is a local, if you need to use remote, just remove the local, and you can put the ID, site ID, and you can connect through radio or line 1, and you can monitor directly. So these are the functions and overview of the ladder logic for the STS application. Now I will close this application. See, now once you change everything, you already compiled all the application. So once you compile, you can save the application here. Now we can open the existing application. For that, you have two options here. You can give open, or you can go to file and give open project. See, now the other project, you need to browse your application in particular location. In the desktop, I already have one application called SO Azure _ Finder. Okay, from here just open your application. So it will be added in your system designer STS tool. See, this is my application. Here see, I have one FIU and there is many RTUs. This all RTU, it is connected with this FIU. You can see the architecture here. See, this is my architecture, exactly how it is connected with my network. I already explained before, no? So you have already, there is many, you can make the network here, network manager or radio communications or IP IP conversion, IP, everything. If you, when you link, it will be linked like this. See here you have RS link 19, radio 1 by 1, line 1. There is 3 links connected together, not 3, 4 links totally. Okay, in this project. So I will open one of the project. See, I will open IPS1. See here, I use, this is my site ID and this is my site name and firmware version and descriptions. What I explained earlier, the same things. And here if you see, there is one application already, IPS6.adb. Okay, and if you go for ports, what we already configured for radio 1 XPR radio, and this radio is a Motorola radio. It is dedicated mainly for Motorola radio communication systems. And for the second one, I used for RTU to RTU communication. This is for interlinks between the RTUs, and it's connected with RS link 19. And for S serial 2, I connected with local computer, and this one I make 100,000 115200. So, and also for Ethernet, I connected with TCP IP static Ethernet, and my IP address is 192.168.0.1, because I am using this one for LAN connection as well with GSM. Here I can connect, see here I can use one for radio, one for GSM also. So it is possible to connect your system with external modem also, or also like you can connect through the radio. Whatever the connection you need, you can make as per your design. Okay, and for this application, I explained you before. Once you created, it will automatically create 3 parts like database, process, IO link. From the database, it will automatically create these 3 tables: user tables, system tables, and constant table. User table I already explained before. You have to create this user table. And for system tables, it will be automatically created by the software itself. And for the constant table, it will be created by software also, but this is all constant values, and this is the system values. And for this user tables, we have to create. Usually when you create a default, it will create only your qualifiers. Even inside the qualifiers, we have to create this all what we need in our project specifications. And if you go for use, this table is used for communicating between. This application is dedicated for irrigation networks and irrigation pump station. So it's already created with DO, DI, and AI, AI2, AO, and AO2. So this is already created. And for the ticks and flow, it is used for flow calculation purpose internally. And we already created for timers and also for user flag bits. So we created user flag bits and digital inputs. See, we added the digital inputs, and also we added for digital outputs, analog output, analog inputs, and physical, logical, like this. See, once you go there, this is the generic application I told you before, and this application No, this application is not exactly generic. It is irrigation. See, this application is made for IRINET. So this is work for irrigation network, and we made a process control for the irrigation systems. We have some pumps and it is going to control through the irrigation network. So we added these logics. And for the IO link, I told you before, you have to link the IO signals from the inputs, and you need to connect with that output for the physical output through these IO links. And in the next section, we will make the communication between the Motorola RTUs and our application, and we can see how to download, how to upload, how to check the date and time, and monitor the signals, everything. We can see on the next video soon. Thank you for watching this video. If you not subscribed, subscribe this channel and press the like button, and share to your friends. So we will see on the next video. Thank you.